Okay, students, today we are going to continue our study of quadrilaterals by focusing on a rhombus, a rectangle, and a square. First of all, let's start with our vocabulary terms. And the first one is a rhombus. A rhombus happens to be a parallelogram with four congruent sides. Okay, so I'm going to choose a color, and I'm going to draw, usually when we draw a rhombus, it kind of looks like a slanted square. Okay, so here, and you have to mark all the sides congruent. Okay, I'm going to underline this in blue. My rhombus is blue. Okay, next, a rectangle is also a parallelogram. And this parallelogram has four right angles. Okay, so when I draw this one, I'm going to choose a color. This one's going to be green. And normally when we think of a rectangle, we usually think of it as having a pair of longer sides and a pair of short sides. Okay, and since there are four right angles, I'm going to draw the right angles. So that's normally how we see a rectangle. But remember, it's a parallelogram, so opposite sides are parallel, and it has four right angles. This shape right here is also a rectangle, and that rectangle looks very familiar. It looks like all the sides could be the same, and that's true, it could be. Next, a square. A parallelogram with four congruent sides and four right angles. Okay, so this time I'm going to draw the square, and when we label our square in our diagram, we have to label it with all the right angles, and we have to show all the sides are congruent. So that's why this one, even though it looks like it could be a square, it's not marked correctly. So I'm going to highlight this one in yellow so you can see all the markings. And that's a square. Okay, so we have a few corollaries, and corollaries are kind of like postulates and theorems. It's just an extension of the definition. So the first one I have is the rhombus. The rhombus corollary. It says that a quadrilateral. Okay, so now if you look at the definition starts with a parallelogram. Well, we know a parallelogram is a quadrilateral, but see how it's an extension, because here we start with the word quadrilateral. So a quadrilateral is a rhombus if and only if. Now remember, that's usually just for definitions, because definitions go both directions. So if and only if it has four congruent sides. Okay, so over here, A, B, C, D is a rhombus So I'm going to draw it for you. So here is A, B, C, D is a rhombus. If and only if, remember how we shorten that? IFF, if and only if, we know that a B is congruent to BC, which is also congruent to CD, which is congruent to DA or AD. It doesn't really matter. Okay, so these are in blue. Rhombus, all these sides are congruent is what it's saying. That one's congruent to that one, which is congruent to that one. Next, I have a rectangle corollary. Okay, it's going to be an extension of this. So instead of starting off with parallelogram, we're going to start off with the word quadrilateral again. A quadrilateral is a rectangle if and only if it has 4 right angles. So it's not exactly the definition, but it's taking the definition and expanding it a little bit. Okay, so here, A, B, C, D is a rectangle. So here's my drawing. A, B, C, and D, going all the way around, is a rectangle if and only if, so I'm shortening it, if and only if, I know that angle A, angle B, angle C, and angle D are right angles. Okay, so that was in green. So if and only if angle A, angle B, angle C, and angle D are right angles. So there you go. Alright, the last corollary today is the square corollary. And of course it's going to start off the same. A quadrilateral is a square if and only if it is a okay, so this one says it has 4 congruent sides and 4 right angles, but it's saying if it is A, so it's asking for it to be something. So it's asking it for it to be a shape. If it's a rhombus and a rectangle. Okay, so that means that we have to make sure that it has all these sides congruent and all of these angles are right angles. Okay, so A, B, C, D is a square. And here's my drawing. A, B, C, D is a square if and only if angle A, angle B, angle C, and angle D are right angles, and so it has to be all of these, and AB is congruent to BC, is congruent to CD, is congruent to AD. All of those sides are congruent. So now I'm going to color code it for you. I've got my blue showing you all the sides are congruent here. So it has to have that, and it has to have the right angles. Okay, so the corollary is just extending the definition to a quadrilateral, a 4-sided shape. All right, theorems. Now, theorems are what we prove, remember. They can be proven. Corollaries and definitions are just understood. We just accept them. All right, so the first theorem that we're going to talk about today says a parallelogram is a rhombus if and only if its diagonals are perpendicular. Okay, so I'm going to draw my rhombus over here. So I'm going to start off here. This little symbol here that looks like a slanted rectangle or slanted square stands for parallelogram. So parallelogram ABCD is a rhombus Okay, here's my picture. A, B, C, D is a rhombus if and only if AC is perpendicular to BD. Okay, so I'm going to draw that. I'm going to choose a color. I'm looking for these perpendicular segments. So AC and BD, these, and remember, to show perpendicular, we just draw one little right angle. Those are perpendicular. All right, next page. All right, we have two more theorems. The first one says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, so now for my picture, I'm going to start off with that little symbol again, parallelogram. A, B, C, D is a rhombus. And then here's my picture. A, B, C, D is a rhombus if and only if AC bisects angle, so this AC right here, AC, it's bisecting this angle here, the BAD angle, and it also bisects this angle over here, BCD. Okay, well, we have two diagonals, so there's the first one, AC, and we have BD. So here's this one, BD. And we know that BD bisects, that means to cut in half, bisects angle ABC and angle ADC. Okay, so here's this one here, the red one, and here's the purple one. So you can go back and see where you found it. Where did that come from? All right, next theorem, last theorem for today. We have a parallelogram is a rectangle if and only if its diagonals, oh, it has an extra, that's a typo, so you can just cross that out. if and only if its diagonals are congruent. Okay, so again, start off with the parallelogram symbol. Parallelogram ABCD is a rectangle. Okay, let's draw a rectangle and label it. ABCD. Okay, so is a rectangle if and only if AC is congruent to BD, because those are the diagonals. So again, here's BD, BD here, and AC here. Those two segments are congruent. Okay. Now let's take a look at an example that you might see on a quiz, test, or homework, or practice workbook problem. It says, if I am a parallelogram, so all those facts about parallelograms that we've been using apply. So look at this picture here and say, this is a parallelogram. Who am I? Okay, well, you've got all four sides and you only have two, but remember, in a parallelogram, opposite sides, or opposite angles are congruent. So if this is a right angle, you know this one is. If this is right angle, this one is. So that is if you look at the definition, that should be a square. Okay, now this one, it's a parallelogram. So, and the only thing they have marked are four sides congruent. And if you look at the definition and the corollaries, we know that a quadrilateral with four sides congruent, we're going to call that a rhombus. Okay. Now, the next one, we have this quadrilateral here. We do know it's a parallelogram, so we're going to apply our knowledge of parallelograms. That means opposite sides are congruent. Well, that's already marked. But we also know that consecutive angles, remember, these two are consecutive angles, and they are supplementary. So if this is 90, then this has to be 90 in order for the two to add up to be 180. So we know this is a right angle as well. Opposite angles are congruent, so that has to be a 90-degree angle as well. Therefore, we have this quadrilateral here, and we know that all four angles are right angles. Therefore, because of definition and the corollary, we know that this is a rectangle. Okay, next we have this rectangle RSTU, and they're telling us that US, this diagonal right here, US, so the purple one, is equal to 6x plus 3. And then RT, so this diagonal here, is equal to 7x minus 2. And we just learned up here in this theorem that these two segments, the diagonals, must be congruent if it's a rectangle. So I set them equal to each other. And so I know that 6x plus 3 must equal 7x minus 2. Okay, so I'm going to subtract 6x from both sides. I get 3 on the left equaling x minus 2 on the right. Now I'm adding 2 to both sides, so I'm going to get x equals 5. In the next one, we know that this is a rhombus, and here, since it's a rhombus, I know that all these sides are congruent. I also know that the diagonals bisect the opposite angles. So let's take a look at which angles we're talking about. Alright, so first of all, I'm going to use a color to highlight this one. It says STR. STR. We're talking about this angle right here. we know that angle is 8x plus 3. Okay, now this one here, UTR, this one here, UTR, this one here, okay, belongs here. Now, remember that when it's a rhombus, the diagonal bisects the angle. So that means this angle and this angle are congruent. So we set these two algebraic expressions equal to each other. So that's going to be 8x plus 3 equals 16x minus 9. Subtract 8 from both sides. I get 3 on the left equaling 8x minus 9 on the right. Okay, add 9. I get 8x equaling 12. And here I'm getting a fraction, and that's okay because this is a fraction 12 over 8, which reduces to 3 over 2. If you put it in your calculator, you'll get 1.5. And either 1.5 or 3 over 2 is going to be a good answer for this one. Okay, next. All right, on this page, we're going to refer to this rectangle up here. And notice how traditionally when we name we say A, B, C, D is a rectangle. Usually we put A, B, C, D in around the angle, but this one just happens to be named differently. So this up here should be A, B, D, C is a rectangle. Okay, so that's a typo, so go ahead and change that. All right, so now we've got to think about, because a rectangle is a parallelogram, we've got to think about all our parallelogram facts, and we have to think about our rectangle facts. Okay, so here I've got AE and DE. So let's label those. AE is this one, and DE is this one. And what we know is that in a rectangle, the diagonals bisect each other. They're congruent and they bisect each other. So this green segment and the yellow segment are congruent. So we set these two equal to each other. 36 equals 2x minus 4. I'm going to add 4 to both sides. Then I'm going to divide by 2 on both sides. So that means x equals 20. Okay? All right, that's the first one. Okay, now here, BE and CE. Again, these are both BE and CE. Those are diagonals. So you know they're going to be set equal to each other because they bisect each other. So I'm going to write 6y plus 2 is equal to 4y plus 6. And I'm using the same concept here. I'm going to subtract 4y from both sides. I get 2y plus 2 on the left equaling 6 on the right. Subtract 2. I get 2y equaling 4. Now divide both sides by 2, and I get y equals 2. Okay, next. It says BC. BC is the whole line here, the whole diagonal. That's BC. And AD is this whole diagonal. So on the other page, we highlighted these in purple and in red. So I'm going to do the same thing to try to remind you that these are diagonals. And remember, diagonals of a rectangle are congruent. So we set them equal to each other. That's going to be 24 equals 5y minus 1. Add 1 to both sides. You get 25 equals 5y. Divide by 5, divide by 5. You get y equals 5. All right, almost done. Example 7. If BEA is 62, okay, well there's some information. BEA, this is 62 degrees. Find BAC. BAC. I want this angle right here. This is a rectangle. And what do we know about rectangles? Well, rectangles have 4 right angles. So we know BAC happens to be a right angle. So do we need this information here? That's just extra information we don't need. The measure of angle BAC is equal to 90 degrees. Alright, next. I'm going to erase some of my marks up here so we can see what's going on. Okay. AEC. AEC happens to be this angle right here, and this angle is 12x. BED, this guy over here happens to be 10x plus 20. And they want me to find AEC. Well, these happen to be vertical angles, and we know that all vertical angles are congruent to each other. So I'm going to set these two equal to each other. 12x equals 10x plus 20. I'm going to subtract 10x from both sides. That's going to give me 2x on the left equaling 20 on the right. Divide by 2, divide by 2. I get x equals 10. Now, did they say find x? No, they said find this angle. So that means I have to plug this back in. So here, the measure of angle AEC is going to equal 12 times 10. So the measure of angle AEC is 120 degrees. Now I found the answer. It's not this one, it's this one. Okay, BD. BD right here is this segment right here. And then AC is going to be this one up here. Now, because a rectangle is a parallelogram, we know that opposite sides are congruent. So AC is congruent to BD. So that means we can set these two equal to each other. That means that 8y minus 4 must equal 7y plus 3. Subtract 7y from both sides. I get a negative 4 on the left equaling, oh, I'm sorry, I get a y minus 4 on the left equaling a 3 on the right. Now add 4 to both sides. I get y equals 7. But they didn't ask me for this. They asked me to find BD. So now I'm going to have to take this information and I'm going to have to plug it back in. So I know that BD, since it equals 8y minus 4, I'm going to put 8 times 7 minus 4. 8 times 7 is 56. 56 minus 4, that's going to be 52. So BD equals 52. All right, now the last one. Okay, so the last one says that AB is 6y. So I'm going to draw that down here. AB, that's 6y. And BC, oh, I'm sorry, this should say BD. It's a typo. BD, which is down here, BD, that's going to be 8y. I want to find, that's a typo, AD. I want to find this right here. Well, if I draw it, if I take it out of the picture and redraw it over here, it's easy to see because this is a right triangle. So I can use Pythagorean theorem to find this. A squared plus b squared equals c squared. I'm going to put 6y squared, and I'm going to have to square the whole thing, plus 8y squared is equal to c squared, or ad squared. I'll put that. Alright, now when I square this, I have to square the number and I have to square the variable. So this is going to be 36y squared plus, and this is going to be 64y squared equals ad squared. Now, since these two are like terms, I can add the numbers together. So that's going to be 100y squared equals ad squared. And yes, I'm going to take the square root of both sides. Now you're probably looking at this and saying, oh my gosh, I can't do this. But you know that you can separate these. That's 100 and that's y squared. So that might be easier for you to see that this is just 10y. Okay? So it says you want to find AD in terms of y, so it's going to have a y in the answer. So we found that this was 10y. Now, take a look, a very close look at this. That is really a Pythagorean triple, sort of. It has a Pythagorean triple pattern. You can see this as 3 times a number, 4 times a number, 5 times a number. It has the pattern 3, 4, 5. So this is like 3 times 2. This is 4 times 2. So this was a 5 times 2. So you really didn't need to do any math to figure this out if you remembered your Pythagorean triples and just looked for the pattern. All right, students, we are done today. That is it for Notes 8.4.